Hello everyone, welcome back. This is the third lecture of our linked list series, and in this video we are going to look at the problem merge two sorted lists. Again, this is a very standard linked list problem, and it is very often asked in interviews. So according to the problem statement, we will be given heads of two sorted linked lists, list 1 and list 2, and our task is to merge the two lists in one sorted list. And it states that the list should be made by splicing together the nodes of the first two lists, and we need to return the head of the merged linked list. So basically we will be given two linked lists, and the values of the nodes of those two linked lists will be in sorted order. So both the lists will be in sorted order, and we need to merge these two sorted linked lists in one single sorted linked list, and we need to return the head of that merged linked list. So this was the problem statement. Now let us see the approach to solve this problem. Okay, so we will see two approaches to solve this problem. So in the first approach, what we are going to do is we will compare the node values of the two linked lists, and gradually we will create a new linked list. Okay, so as the two linked lists is in sorted order, we are going to iterate through them simultaneously, and while comparing the values of the nodes of the two linked lists, we will create a new linked list. So let us walk through the algorithm, how it is going to work. Let us see that. So let us assume that the head of the first linked list is L1 and head of the second linked list is L2. So what we are going to do is we will compare the values of the nodes pointed by the L1 pointer and L2 pointer respectively. So in the beginning, as you can see, the node pointed by L1 pointer is having value 2, and the node pointed by L2 pointer is having value 3. As this node is smaller than the node pointed by L2 pointer, we are going to create a new node, and this node will have value 2. After this, we are going to increment our L1 pointer because we are done with this node, so we are going to move ahead. But L2 pointer will stay the same. Now again we are going to compare the node values. As 3 is less than 5, so we are going to select this node. So the next node will have value 3 in our new merged linked list. Next node will have value 3. Now as we did before, now we are going to increment our L2 pointer ahead because we are done with this node, but our L1 pointer will stay the same. Now again in the next step, we are again going to compare the node values. This time node with value 4 is having value less than node with value 5. So as this node is less than the node pointed by L1 pointer, our next node will contain value 4. So I hope it makes sense. This is a very basic merge algorithm. We are one by one comparing the node values, and we are gradually creating our newly merged linked list, which will be in sorted order. So the next node will have value 4. Now as we are done with this node, we are going to increment our L2 pointer to the next node, but our L1 pointer will stay at the same node. Now again on comparing, we can see that L1 is having value 5, whereas node pointed by L2 is having value 8. As 5 is less than 8, so our next node will contain value 5. So our next node will contain value 5. Now After this, we are going to increment our L1 pointer as we are done with this. Now again in the next step, we are going to compare the node values. As 6 is less than 8, the next node will contain value 6. And we are going to again increment our L1 pointer ahead. But our L2 pointer will stay at the same node. Now in the next step, what will happen is that when we check, so we will find that L1 has reached null. It means that we are done with our first linked list and it is completely exhausted. There are no more nodes left in the first linked list. The two linked lists which will be given to us, both the linked lists will be in sorted order. And as we are done with the first linked list, but here you can see that in the second linked list there are still some nodes left. So straight away going to attach all the nodes, all the remaining nodes from the second linked list at the end of our newly created linked list. So we can join the next of this node to L2 pointer, because there are still some nodes left in the second linked list. That's why, and as the second linked list is also in sorted order, so we can add the remaining nodes directly at the end of our newly created linked list. Okay, so I hope it makes sense. So this was the first approach where we simply compared the values of the nodes of the two linked lists, and we created created an entire new linked list out of these two linked lists. So if I talk about the time complexity, it is big O of n plus m, where n is the size of the first linked list and m is the size of the second linked list. And space complexity of this algorithm is also big O of n plus m, because in this approach we have created an entire new linked list from scratch. That's why the space complexity is also big O of n plus m. So I hope it was clear. And as you can see that this approach is not an in-place solution, and in our problem statement we need to use the nodes of the two linked lists and merge the two of them. But here we have created an entire new linked list. So this is not the optimal solution, but it is one of the solutions which you can definitely tell to your interviewer. So now let us see the code of this approach. So we will be giving heads of the two sorted linked lists, and here what we are doing is we are returning the result from our merge function. So I have written a separate function in order to merge the two sorted linked lists. Now in this function, what I am doing is I have created a new node. So this node is the beginning of our new linked list. So we are going to create an entire linked list from the scratch. So I have initialized our result and temp node and temp pointer, which will be pointing to this dummy node in the beginning. And then here we are checking while L1, which is the head of the first linked list, and L2, which is the head of the second linked list, while these two pointers are not pointing to null, it means that both the pointers are pointing to some particular node of their respective linked list. So we are comparing the values of the two nodes pointed by the two pointers. If the value of the L1 node pointed by L1 pointer is less than the value of the node pointed by L2 pointer, we are creating a new node here, and the value of that node will be the value of L1 pointer node. And after creating this node, we are incrementing our L1 pointer to the next node. And else, if the value of L2 pointer node is less than the L1 pointer node, we are creating the new node with the value of L2 pointer node. Okay, and we are incrementing our L2 pointer in the other case. So after these two conditions what we are doing is we are doing temp.next equals to node. So the node which we have created, we are assigning temp.next to this node. Okay, and after this we are incrementing our temp pointer also to the next node. So this way our merged linked list will be gradually constructed, and if any one of these two linked lists get exhausted, we are going to break out of this while loop, and at the end we are going to check if L1 pointer is still there are still some nodes left in the L1 pointer, but the L2 pointer got exhausted, L2 pointer got reached the null, we are going to add the remaining nodes at the end of our merged linked list. Similarly, if our L2 pointer is still having some nodes in the second linked list, but our L1 pointer reached null, so we are going to add the remaining nodes from the second linked list at the end of our merged linked list, which we are constructing. Okay, so we have already discussed this. Now at the end we are going to return result.next because merged linked list will be from the next of this dummy node, and we are returning the same. So I hope this approach was clear. Now let us see the second approach to solve this problem. So in the second approach, we will merge the two sorted linked lists in place. So for that, we will be giving the heads of the two linked lists L1 and L2 pointers. Now we'll be merging them in place, which means we'll be using the nodes of these two linked lists only, and at the end we will have the sorted merged linked list. Now in what we need to do is we need to initialize a sentinel node. So a sentinel node is basically a dummy node which is used for traversing any linked list. So here we have initialized a dummy node and we named it answer, and also I have taken a temp pointer which will be in the beginning pointing to this answer node only. Now we are having L1 pointers pointing to the head of the first linked list and L2 pointer pointing to the head of the second linked list. Now in our algorithm, what we are going to specify is that we always want that the node pointed by the L1 pointer should always have the smaller value. Okay, so we are specifying that the node pointed by the L1 pointer should always have the smaller value, so that the next node that we want in our merged linked list should be the node pointed by L1 pointer. Okay, so I hope the point was clear. How this will help us in tracing the newly merged linked list, because we will know that the next node will be the node pointed by L1 pointer. So in the beginning we are going to compare, and we will see that node with L1 pointer is having value 3, but node with L2 pointer is having value 2. As 2 is less than 3, it means that we need to swap L1 and L2 pointers. So after swapping, L1 will point to node with value 2 and L2 will point to this node. Okay. Now we are going to begin our algorithm. We will be needing a pointer which should point to the previous node also, while we gradually iterate through the linked list. So for that we need our previous pointer also. So we will initialize it here. Okay, we want previous pointer to point to the previous node of the L1 node. Okay, now so as L1 pointer, as the node pointed by L1 pointer is having lower value, what we are going to do is, so we are going to make previous point to this node, and next we are going to make the next of temp node point to the node L1 pointed by L1. So after doing this, we are going to increment our L1 pointer, but our previous will point to this node only, which is the previous of the new L1 node. After this, again, we are going to compare. Now, as here you can see that node pointed by L1 pointer has value 4 and node pointed by L2 pointer has value 3. But as we discussed, we always want that the node pointed by L1 pointer should have the lower value. Hence, we are going to again swap L1 and L2 pointers. Okay, now again, as L1 pointer is pointing to a node with lower value, what we want is also in the previous step we are going to increment our temp pointer ahead. I forgot to increment our temp pointer. After this, as our L1 pointer is having lower value, again we are going to do the same thing. We will make the next of the node pointed by temp pointer point at the node pointed by L1 pointer, as it is having lower value. And we are going to increment our previous pointer to this node only. And we are going to increment our L1 pointer again. Okay. And after this, temp will also be incremented to this node. Now again we are going to check, but as you can see, L1 pointer is no longer pointing to the node with lower value. So again, it means we need to swap L1 and L2 pointer. And now as you can see, L1 pointer is pointing to the node with lower value, which means that the next of the node pointed by temp pointer, which is this node. So the next of this node will now point to the node pointed by L1 pointer. Okay. And we are going to increment our previous pointer to this node, and L1 pointer will be incremented. Now we are going to increment our temp to this next node. So as you can see, gradually we are getting our sorted merged linked list. We are using the nodes of the two linked lists only. We are not creating any new node. Now again we are going to check, and as you can see, L1 pointer is no longer pointing to the node with lesser value. That's why again we are going to swap L1 and L2 pointers. Now here again the next of the node pointed by temp pointer, which is this pointer. Now next of this node will point to the node pointed by L1 pointer, and we are going to increment our previous pointer. So previous will now point to this node, and L1 pointer will be incremented. And the same way we are going to increment our temp pointer also to the next node. Again we are going to compare, but as L1 pointer is still pointing to the node with lesser value, we are going to do the same thing. So we are going to continue because the next of the node pointed by temp is pointing to this node only. So we are going to continue. So L1 will be incremented to the next position. But our L1 pointer has reached null, and also our previous pointer will point at the node with value 6. Okay, so we actually don't need this temp pointer because our previous pointer alone is enough to reshape the two linked list in order to merge the two linked lists. So we basically don't need this temp pointer, so we can keep it aside. Now our L1 pointer has reached null. It means that all the remaining nodes in the second linked list, as it is already in sorted order, we can directly append them at the end. So what we need to do is we will point the next of the previous node to point at our L2 pointer node, and then from here our entire list is sorted. We don't need to iterate till the end. And as you can see that our both the two lists are now sorted. All we did was we used two pointers L1 and L2, and we made sure that the node pointed by L1 pointer is always pointing at node with lower value. And then gradually we are merging the two lists. Okay, so I hope this approach was clear. It is also a very simple approach. It seems to be a little bit complicated, but it is very easy to code. So now let us see the code for this approach. So we'll be given the heads of the two sorted linked lists. So here we are returning what we will get back from our merge function. In our merge function, firstly we are checking if our L1 is null, we are returning L2. If our L2 is null, we are returning L1, which means that if any one of the two links is null, we are returning the other sorted list, because that will be our answer. Here we have created our sentinel node and I named it as result. Now in the next step we are checking. As we discussed, we always want our L1 pointer to point at a node with lower value. So here we are checking. If node with L1 pointer is having greater value, we are swapping the two pointers. After this, our L1 will always point to the node with smaller value. Then here what we are doing is we are doing result.next, and it will point to the node pointed by L1 pointer. So after attaching the node pointed by L1 pointer, we are going to begin our process, our merging process. So while L1 is not null and L2 is not null, so if any of the two pointers reaches null, we are going to attach the remaining nodes which will be pointed by the other pointer. We are going to append those remaining nodes at the end of our merged list, and then our task will be done. So while L1 is not null and L2 is not null, we have taken a previous variable which will point to the previous node of the node pointed by L1 pointer. And while L1 is not null and value of L1 node is less than equal to value of L2 node, we are going to continue. We'll increment our L1 pointer to the next node. We'll keep doing this as long as our L1 pointer node is having less value than the L2 pointer node. And at the same time, we will keep incrementing our previous pointer also. But as soon as our L1 has the node pointed by L1 pointer having value greater than the L2 pointer node, then we are going to break out of this loop, and what we'll do is we'll do previous.next and we'll make it point to the L2 pointer node, and after that we will swap L1 and L2 pointer, because we always want our L1 pointer to have node with smaller value. That's why we will swap the two pointers, and again the same process will be done. We will repeat the same thing, and at the end, so we will return the next of our sentinel node, which will yield us the sorted merged linked list. This was the in-place solution to solve this problem. The time complexity of this approach is also big O of m plus n, but the space complexity is constant because we are using the nodes of the two linked lists only. And if I submit this, this should get accepted. Solution is also accepted. So this was it for this video, and I hope you liked the explanation. So thank you and have a nice day.